This is a 1.3 vector equation. This one is an introduction to the vectors. So we're gonna dive deep to vector equation is chapter 4. Just we're gonna introduce what is vector, what is vector operation, guys. What is vector? Vector is R2. Vector is ordered list of number. Vector form is looks like here is right. It looks like this form is going to be 2 element, 3 element. We call it vector. Vector is column vector, meaning is you're going to put the vector is list of numbers one column. Okay, for example, 1, 2, 3, or 1, 2, we call this is column vector. So we are really interested vector in R2. What does it mean by vector in R2? So guys, here is R2. Vector is R2 meaning is R is real number. Here is the number of element. So vector is R2 meaning is you have a column vector. It looks like this. That's the vector. How many element? Is make sure 2 element, 1 and 1, or 0 and 1. Here, negative 1 and 2. That's all about vector in R2, guys. R2, okay? So we're gonna do R3, R4 later, guys. So now we wanna sketch the vector in R2. How gonna sketch it? So R2 is you have 2 elements. So how gonna sketch vector in R2, guys? Let's talking about coordinate plane right there. For example, here is 1 and 1. You think this is x value, here is y value. We're gonna see here is x1, x2. You're gonna plot the point 1 and 1. X value is 1, go to the 1, go up 1. That's the 1 and 1. You're gonna sketch the vector. Sketch it from the origin. That's represent vector 1 and 1, guys, okay? So another example, 0 and 1. Let's go 0 and 1. X1 is 0. X2 is 1. So 0 and 1 is right there. That's another vector, okay? Make sense? Negative 1 and 2. Here is x1 value. Here is x2 value. Negative 1 right there. 2 is right there. So you're gonna find the negative 1 and 2 value. Gonna connect it. That's the vector. That's how to sketch the vector in the R2, guys. All right. Talking about how we're gonna do addition, how we're gonna do scalar multiplication, guys. Let's talk about vector is v1, v2, w is w1, w2. So we're gonna add vector. So vector is gonna be here. So that case, you're gonna add the first component, the second component. Okay, first component v1 plus w1, second component v2 plus w2. That's what we call that's the vector addition of vector. Another important is scalar multiplication. Scalar is not different from the vector. So we're gonna define the CV here right there. How can define it? C is any real number. So we're gonna define CV1, CV2. Guys, make sure we are not talking about vector application. Make sure scalar C value is any real number, okay? So how gonna sketch the addition and scalar multiplication, guys? Briefly, I'm gonna explain this way, guys. We're gonna parallelogram rules for the addition right there, guys. Look at this one. How can sketch it of addition of two vector? So here is a v vector. Here is a v vector. I'm gonna sketch it first. Here is w vector right there. Then when you do the addition, make a parallelogram. Then we're gonna connect it to this point. That's parallelogram. We're gonna call this is v vector plus w vector. That's how to sketch addition of two vector, guys. Okay. How about scalar multiplication? There is gonna be very careful with the c value. C is positive, c is negative. Let's sketch the v vector here, guys. Let's say here is a v vector. That's the V vector. When you C is a positive, for example, C is 1. So here's a V vector. You're going to sketch to here. So we're going to talk about 2 value 2. Stretch by 2, guys. So this one is going to be 2V vector, okay? Multiply 2, scalar multiplication. All right, C is negative. C is negative 2. Negative meaning is opposite direction. We're going to sketch the negative 2V vector is opposite direction. So that's going to be negative 2V vector. Guys, make sense? So addition and scalar multiplication. So here is an example you guys practice it first. Addition of two vector. How can define it? This one, guys, each component. 2 plus negative 6, 2 plus 1. So that's going to be negative 4 and 3. So let's just sketch it. Parallelogram rules. 2, 2. 2 to right there. Then connect it. That's the U vector. Negative 6, 1. Here is negative 6, 1. That's the V vector connected from origin to this point. That's the UV vector. Addition, addition. Parallelogram, guys, parallelogram. You're going to sketch the parallelogram right there. Here is right there. This one is U plus V vector. What is this vector going to be? This point going to be, guys? This point going to be negative 4 and 3. That's how to sketch the addition of two vectors. How about this one? Let's just sketch the scalar multiplication before we sketch this vector. Let's find the scalar multiplication. Okay, how can define it, guys? 2 times the first component, 2 times the second component. This one is 6 and negative 2. Everything makes sense? How about this one? Negative 2 over 3. Negative 2 over 3 times 3. Negative 2 over 3 times negative 1. That's how to calculate scalar multiplication. This one is negative 2. This one plus 2 over 3. That's the scalar multiplication. How gonna sketch this scalar multiplication? Through the coordinate plane. Let's sketch the U vector 3. Negative 1, that's the here. That's the U vector. U vector, right? 2U. 2U. You have doubled that direction, guys, okay? That direction. 2U gonna be this one. This one is 1. This one is another one. So this one is 2U. What is this point gonna be? 6 and negative 2. Guys, make sense? Here is negative 2 over 3. You're gonna sketch the opposite. Opposite. This one is gonna be negative 2 over 3 U vector. What is this point? Negative 2, 2 over 3. You're thinking about this one is, this one's gonna be 2 over 3, okay, compared to U vector. Okay, that's how to sketch scalar multiplication and addition of two vector, guys. Okay. We're gonna generalize vector is Rn. Look at the very carefully, guys. Look at this. This is a real number. This is n. N is how many components in each vector, guys? That you clearly understand that. So vector is Vn, meaning is, guys, V is gonna be vector is Vn, meaning is how many components? Here is n, V1, V2, all the way Vn. That's the n element in the Rn vector, vector in the Rn, guys, okay? Another important vector is 0. 0 vector is meaning is all component is 0. 0, 0, 0, okay? So let's giving one example. Let's say R is 3. Find the V vector is R3. How many components, guys? Make sure how many components? 3, right? So you can write any vector, any real number in the R, 3 component. I'm gonna pick the 1, 1, 1. That's gonna be in R3. Can you have another one? Here is W vector. You're gonna put 1, 1, negative 1. Let's find the 0 vector in R3, guys. That's gonna be 0, 0, 0.